Hi, so I'm Matthew Nunes, and just to let you know, my slides are going to auto-advance. So if I start speaking really quickly, or if I slow down, it's because I'm being led by my slides. So I'm going to be talking about a project at Cardiff University with Pete and Jared, and focusing on our journey towards and within user-centered design. Oops. So the project itself is titled Integrity Checking on the Edge, otherwise known as ICE. And if I were to summarize the goals of our project, it would be to create an intrusion detection system for industrial control system environments. However, an important aspect of our system is that it be designed in a manner referred to as user-centered design. Now, within user-centered design, the system is designed primarily around its users' needs, until, of course, they're completely locked in and can't get out, much like Windows. But more seriously, this is important because it means that rather than looking to the literature or our intuition for what we think the field needs, we look to its users. So to create such a system, the steps you need to take are fairly straightforward. You need to gather data from industrial control systems, develop some machine learning to distinguish normal from attack traffic, provide a user-friendly visualization, and evaluate your creation with industry experts. So if we move on to the first step of gathering data, this step should be the easiest. In a traditional network, you'd fire up some old Windows machines, install some malware, wait for a bit, copy over the data, job done. Within ICS, this is really difficult because the devices you need aren't readily available, and it's generally frowned upon for you to walk into a factory and install malware. So you're left with only two options: use a data set or create your own test bed. Now, the data sets within ICS aren't great, so part of our project has been to create our own test bed. But in the meantime, we've used the SWOT data set from the test bed pictured over there, since it's the best and largest in existence. Now, once you've gathered data, you need to detect attacks. Unlike the data gathering process, detecting attacks within ICS is very easy. If you look at the communications within many test beds, you'll find that 90% of the communications repeats. Communications with your PLCs just goes back and forth and side to side, not side. But also, IDS solutions within ICS aren't actually that new. There are many IDS solutions. There are as many IDS solutions as there are acronyms in PETRAS. So once you can actually detect attacks, the next stage within the design of an IDS is to actually communicate an attack to its users. So currently you're as likely to find a user-centered visualization solution within ICS as you are a conscience in Elon Musk. So we have to search more broadly. Now, if you look at networking visualization solutions, you'll find more, two of which are pictured here. The problems with them is that few have been developed in a user-centered manner, few are open source, few manage with large quantities of data, such as those found in SWOT dataset. So we set out to create a number of visualizations using D3, since that would allow a user to interact with them. And after iterating through and creating a number of designs, such as some of the ones seen here, these are just a few, we arranged a workshop with 3 experts within the industry. Now, our conversations with the experts actually surprised us because they weren't actually concerned with our visualizations, but they just wanted information communicated in terms appreciable by multiple stakeholders. So to provide an example, they talked about being able to express the impact of an attack in financial terms, since monetary values tend to be universally understood. So after our first few interviews, we realized we needed to take a step back and better formalize our requirements. We looked for inspiration in the user-centered design literature within cybersecurity. Now, we discovered that this was quite a sparsely populated domain, almost non-existent, and this didn't come as too much of a surprise since cybersecurity experts aren't known for being particularly personable, but that's maybe something we should work on. But one person who stood out was Sean McKenna. Now, he's produced some incredibly helpful literature on relevant techniques to ensure the solutions you produce are user-centered. Now, he's worked with very big names in the visualization field, names such as Mariah Mayer, Jason Dykes, and others I can't remember. So one of the techniques that was inspired by McKenna were personas. Now, personas are particularly relevant for ICS since the system designed needed to be understood by a wide variety of people, and personas are great at capturing all the competing concerns. And once you have personas, you can then wireframe a complete system around it. So we took our wireframes to the experts, and they were extremely pleased with what we had created. Now, you would think the obvious next step is to design a complete system around the wireframes. However, there are many elements we represented in the wireframes and personas that themselves would take a full PhD to solve. So we've decided to stop there and are in the process of writing up a publication with our findings so far. So in the future, we plan to publish our current findings. We're also working on producing a prototype of the system. Thank you.